is on the dynamic analysis that we have discussed yesterday. But here I would like to continue with the same with the example. So yesterday that we have done with a very rough sample model, but here we are going to run up with like a realistic examples over here and all. So this particular problem statement actually what it says, I've just enclosed the same into the ticket 2 as well. So here you can also see this. So it's like a tutorial number 14, I think. Yeah, dynamic analysis of a generator on an elastic foundation too as well. Okay, so normally for this actually, if we just go here, this is a problem statement. They have like a sandy clay. So over the sandy clay, actually, they are going to place this particular foundation. So the foundation, you can see that they have put up the foundation over here, which is having a 1 meter width. Over that, actually, they are going to place the generator. Now, they were asking us to validate that if a person goes and switch on the generator over there, and because of this, what would be the vibration coming onto the foundation, and what would be the deformation happen on the foundation, and as well as what would be the deformation or the settlements happen onto the soil also that we need to see. And again, after a few hours of generator running, actually again they are going to switch off the generator. Once the generator is in switch off mode, the vibrations are going to be nullified very quickly, or it's going to be take a time. That is what that we need to identify these things at. So the vibrating source here, it is a generator, because you know like when you switch on a generator, it's having a lot of vibrations too as well, and that is the source of in our problem. So it's like founded on a 0.2 meter thick concrete footing with a 1 meter diameter. So now here they have given you like what is the width thickness of your concrete footing. So the concrete footing thickness is around like a 0.2 meter, and the width of it is also like around 1 meter it is having. So we have a sandy clay, over that a 1 meter width and 0.2 meter thick concrete foundation is there. Over that a generator was placed, and now when you switch on the generator, the vibrations will be coming on, and these particular vibrations, because of this, how your foundation is behaving it and how the sand is behaving it. Okay, if you have seen this guys, actually when you just observe any of the very big industries or like a general day-to-day application, I can tell you that when you just look at the apartments, that which is having some 300 houses or 600 houses, the very big constructions we can say, or the shopping malls we can say that. So for these actually the generator backup is a must and should, because they will be running on with multiple escalators, and they are like uh, completely commute with lighting systems only inside this. If there is a no lighting or there is a no air conditioner, we can't able to survive over there, right? So just for these kind of things, there would be like a very huge kind of a generators that we are going to place it over there. And if you observe this, after a few years of a time, we normally see there are a small amount of a cracks generating onto the foundation wherever you place the generator, and the generator is running for multiple days or hours together. Okay, I mean like after a few years of a time, you can see there are some small cracks on the foundations. So that time actually what you do normally you try to fix up that particular crack, or like you can add an additional support by providing additional bolted joints to this, so that the vibrations will not pass on to that particular region more, and we can able to control the cracks over there. This is one example here you have seen. The very other examples is like, if you look into any kind of a manufacturing segments too as well, they would like to place the machines to do their manufacturing operations. And to place a machine actually that we need to place a foundation over that we are going to place the machine. Simply we can't place the machine because of the vibration, and it will slide onto the foundation, so it cannot able to withstand. So for that we need to go a bolting operations. Okay, sometimes actually what will happen if you bolted them also, and when you start doing the machining operation, suddenly your bolts will break, and because of that it will damage a few part of your foundation 2 as well, the cement concrete foundation. So in these particular cases, you have to identify that how many number of bolting locations is also required. So according to that only, I need to design my foundation too as well. Okay, it's all like a interlinked engineering between the multiple domains too as well. So that's why these kind of analysis all comes under the dynamic analysis. So in that particular cases that we are going to see one simple example today, that's what actually we will see. Here, when you just go for this is a sandy clay soil that we have built it as per the dimensions. And then the borehole level, water level, it is exactly at the zero groundwater level that I'm considering it. And now, when you just zoom these particular things over the region, okay, if I just look into the geometry, I see it's all like the other side that we don't have any control. Okay, so but this is only a 1 meter, so 0.5 meters with the foundations that I'm going to model as symmetric conditions. So the symmetry geometry that I've been went over here too as well. And now in the structures module, actually, as I'm doing only the half of the thing, so I need to construct my 0.2 meter thick foundation, that is a concrete foundation. So to model that particular things, actually, I have generated one particular plate element. So the concrete foundations, I can able to create it with one plate element. Okay. So how I'm going to create this as a plate element, I'll show you this. So once if you just go here, you are just going to create a line. So just draw a line. Okay. And now this particular line, actually, you can just simply right click on this, create, and then you are going to create it as a plate element. And then you are going to assign the plate element material properties. Yeah. Now the question is like, what is the thickness and how we were defining this? It's a 0.2 meter thick concrete that we were taking it, right? So to look into the material properties that we have used it, sorry. Okay, so if you just go for to the plate elements, and this is the footing that we have used it. So let's save this particular footing is also into my global things. And when you just edit for this one, here you can say that uh, the Young's modulus multiplied with the area 1, I'm just going it as like 7.6. And you know, guys, the thickness of that, it is giving it as something like around 0.2 meters of the thickness that we were going for this, right? So based upon that particular thickness and the length that we know, so we could able to calculate the area 1. That's why that we could able to calculate the area 1 over there. So as we know the length and as we know the thickness, so that's where we can able to calculate length into width that we can do. And that particular area is multiplied with my Young's modulus, and that's where actually this value it is going to come. The Young's modulus of your concrete multiplied with the area. So and then the similar way, actually, as we know the height and as we already know the width too as well, it's easy to identify the inertia to calculations. So from the inertia and multiplied with an E, it gives you the EI values and all. And now the W is something like 5 kilonewton per meter square. This is where something like up to that particular stress, your concrete can withstand it. But beyond that, if it is going, then your concrete is having some kind of a failures over there and all. Okay, so this is how actually that you can do this. 0.1947 would be similar to that. Approximately, we can consider that as a 0.22 as well. So 0.194719. So similar to that of the calculations, it is almost all reaching to your 0.2. So this is how that you can able to provide these particular values, and then finally you're fixing arriving these particular things. So this is how actually into your footing that you are providing the thickness values to as well. I hope like now you got a realistic idea. If you got like thickness and the way you calculated the inertia and the way you calculated the area, it is correct or not, your thickness will support you over here. Okay, which is nearer value is always unacceptable because it's a mathematical calculation. So 100% to 100%, we can't derive it all the time. It's true. So now we got it, and the ultimate strength of my concrete also that I've been passing over here, and that's all good. So that's where I have just created a plate element and then assigned that with this. After creating the plate element, over that actually what happened is like I've just created the plate, and this particular plate is nothing but my concrete footing. Over the footing actually I'm going to place my generator over there. So over the footing, if I would like to place the generator, I really would like to calculate what is the size of my generator, height of my generator, width of my generator, weight of my generator, all these things, all the dimensions of it is must and should for me. But I'm not going to model the realistic generator here. I'm going to model a virtual generator. So the virtual generator on these particular footing, how much amount of a space that the generator is occupied. I'm assuming that it's a 0.5 meters full space it is occupying it. And what would be the weight of my generator? So here it is like 50% it is distributed, and to the other side of 50% it is distributed, right? So I am just going to select this one. I create a line load, and to this particular line load that I'm going to apply my weight of my generator over there and all. Here I have not applied. I've just simply kept it as a 1 and -1 because okay, I have not calculated the weights and all. Yeah. Next, this is where like I could able to build the soil. That's the initial stage. Over that I could able to place the foundation, concrete foundation. Over that I have placed the generator. Till this is all your plastic calculations. The next coming on to this, actually what happened, I just wanted to understand when the generator is in on switch on mode. So when you are switching on this particular generator, then automatically there might be a huge vibrations are generating, right? So these particular
Hello, hello.
Hello.
I think we lost him now. We lost his voice now.
Ah, yeah.
Okay. పోయినట్టుంది భరత్
అన్నా
పోయినట్టుంది.
ఒకసారి కాల్ చేసి కనుక్కోకూడదు.
hello, Vivek
Yeah.
and Bharat. Yeah, sorry guys. Yeah, there was some glitch in the internet.
Okay.
Okay, fine. So where exactly you guys we guys disconnected?
While giving the loading.
Okay, fine. Yeah, let's just continue the same too as well. I think Ashok has called me. Bharat, can you coordinate with Ashok and ask him to join back?
Okay.
Yeah, thank you. Yeah. So this is how actually the load in terms of like a harmonic signal and the frequencies also that we were just providing it over here. Yeah, thanks, Ashok. Yeah. So it's an amplitude of a 10 and the phase angle of a 0, and it is like a frequencies. This is all from the catalog also that we used to get it. Okay, just give okay, and we know that how we are giving this one. And just go for the mesh. As you have changed something, like you can do the mesh, otherwise that's fine. Just going for the flow conditions. So the flow conditions is as usual. I don't want this negative and positive interfaces. I don't know why it's got created to as well, but I don't want that particular interfaces at all. Okay, so yeah, this is a boundaries we can say. And then just going to the stage constructions over here. Actually, if you see these things, the interfaces anyways, I'm not activating it. When you just go for the structures too as well, let me delete these particular interfaces so that you won't get any confusions. This is not required for us. Okay, so this is a mesh flow conditions and to the stage construction too as well. So if you would like to do for the mesh, go always try to suggest go for the fine meshes for the dynamic analysis, though it takes a time, but need to be a very precious analysis that we need, a more accurate one that we need it, right? So go for the medium mesh. And now coming on to the stage construction here, this is where the initial phase one that I'm solving it. I'm just looking for the phase one, which is it a gravity loading or a KO procedure?
Gravity loading. KO procedure, sorry.
Yeah, thanks. It's a KO procedure that we need to follow here. And now when I just go for the footing actually, so what happened is here, I'm just adding the footing. So that's where I have activated my plate element. And then I'm adding my generator. That's where I have activated my line loads. Okay. But if you see this particular calculation is just a plastic calculations. So that means in this that we were not calculating any dynamics part. We were just calculating that one. Okay. So once this is done, the next step is like a start generator. That's where like I switch on my generator. When I switch on my generator for the same thing, I'm going for a dynamic analysis and I'm trying to switch it on for 0.5 seconds. Okay, don't be think that a generator run for half an hour, 1 hour, or 24/7. Okay, this is a dynamic analysis that we are going to. Dynamic analysis, first of all, is an explicit analysis. What do you mean by an explicit? Is like studying the very small deformations. Sorry, in the reverse, I have to tell. Studying the very large deformations in a very small intervals of a time is nothing but your explicit analysis. Or if you're studying your very small deformations in a very large intervals of a time, that's nothing but your implicit analysis. Okay. So here actually we were studying about the very huge deformations. That's where like any impact test is also an impact test. I can't say it's an explicit, it's a kind of an implicit too as well. So any drastic changes, a sudden, like earthquake is the best example. How many seconds a Richter, I mean, the earthquake can happen. For 5 seconds or 10 seconds will create you a huge loss too as well. So that means in a very less interval of a time, we were studying the very huge deformations happening onto the structures. That's why the best example you can remember that an explicit analysis. Okay, so remember that explicit analysis is always suggestible to run for lower intervals of a time. Okay, that's 0.5 seconds. I'm running it over here, and then I've started the generator. And in the modal conditions, I've just make sure that the dynamics is on, and I just wanted to expand this dynamics, and then you can see this X minimum is none that I have selected. If I select this as a viscous over here, what will happen? It will observe the complete vibrations. As this is a symmetry model that I have considered, in the middle, if you observe the complete vibrations, onto the other side also, it is all like we are going to get the wrong results. Okay, but the X maximum is viscous that we can able to select it. Okay, that's where. And the Y minimum is also like a viscous, and Y maximum is nothing. Do you have any doubts on these particular boundary conditions? It's very, very, very important.
In which case we will use that free and viscous.
Sorry, can you repeat again?
I said in which case we will use viscous and free. What
Vector
will be
only I'm understanding.
what will be the scenario for choosing between this viscous or free?
Viscous or
The second option.
free feel.
Yeah.
Okay. See, the viscous is something like when the vibration is coming and hitting this particular boundary, it will absorb 100% and it will not reflect back anything. But the free field is something like when the vibration is coming, it will hit and it will come back.
I'm saying in what are the cases this can happen that a
What are the?
vibration can hit and get back.
1 second, I'll get my earphones. I can't hear you properly. Just give me a second. Hello. Hello.
Yeah, I'm saying, how can we judge that whether the vibrations are reflecting back or getting absorbed?
See, that's all like your choice. Suppose I will tell you an example telling that there is a, I mean, there is a load, it is coming it over here. And because of this, next to this structure, which is a very strong structure, you can say that. But this particular load, it is coming, and next to this of a very strong structure. And when the load is coming it over here, and it is hitting this particular things, in reality, as this is a very strong structure, it will resist for that particular load, and and you know that energy will never destroy, it will be transferred in one form to another form. So as it hit this particular directions, now it will pass on to the other directions. So now because of this particular heavy structures behind this particular things, there might be a chances of this particular load will affect the bottom region a lot actually. So in that particular scenarios, when you are working on it, then you have to go for this particular things. Okay. For example, it is all like a berth constructions. If you see for this particular berth constructions, the water force is a very huge amount of a
Sorry, there was a
force.
power cut at my side. Can you repeat from 30 seconds earlier?
30 seconds. Oh, where I stopped, if you can tell me that, I can tell you that. Where you stopped listening. Hello, Vivek. Am I audible, right?
Yeah, bro.
Yeah, okay, fine. Yeah, Vivek, where you stop listening, let me hint me. So from that, I will start again.
Yeah, there is a. I listened up to there was a powerful structure and energy is neither created nor
Yeah,
destroyed
yeah, yeah.
from that.
So it will come back, right? So it will come back when it is coming when there is a huge, very big structure for you at the side. In that particular cases, you can assume that your boundary conditions as a free field. But when it is not like a very huge structure, I don't want to carry the particular vibrations further. I would like to nullify them. I'm not interested to how it is spreading and how it is affecting. I would like to nullify that particular things and all. Then in that particular cases, I can go with the viscous boundary conditions. If you just go for this, I've just listed the abbreviations of this. This is where a structure it is coming, and the vibration it is generating it over here. So as it is coming and it is hitting these particular walls, if these are the like viscous boundary conditions, this will observe it. And I mean, but the moment when it touches to this particular boundary, the energy will become zero. Okay, but if you don't want, so now what will happen? The vibration it will hit this, and the same line there might be a chances it can come back. So if you want like that such a kind of a things, then it's completely free. Then it's a tight degrees of freedom. It is like it's a user choice to define the constraints for the dynamics. So you can decide it whether you want it to be in the x directions or you want it to be in the y directions and all. I don't know. Someone is breaking you. Okay. Is that clear, Vivek, for you?
Yeah, actually, you continue. I lost the most of it due to power cut. I was coming and going. That is
Okay,
why.
fine, fine.
You
Please go
continue.
through the
I'll watch the
video.
video. No issues.
Yeah, yeah, sure. After that, if you have any doubts, let me know. Yeah. So here actually I've just switch on the generator and make sure that the boundary conditions are also good for me too as well. The reason I just went for the X minimum condition is like none because I'm just going for a symmetry conditions. So that's why I've just chosen it as a none. But here in this particular cases, the full geometry of that consider it. So that's why I can able to consider as a viscous on both the sides. Okay. So that's the difference between that. And after that, when I switch off my generator, so when I switch off my generator, again for 0.5 seconds, I'm observing it. It's also a dynamic analysis. But here, if you see this particular thing, for the loading, actually only the generator weight I've considered and the dynamic analysis, it has been switched off. That means the source of the vibration is I'm eliminating it, but because of the previous step, whatever the vibrations it is there, that I'm trying to calculate it. Now let's go and I'm trying to calculate this. Now you see this, I've just put the play footing. Now because of this particular thing, now I could able to see how actually the amplitude it is coming and going on. How the amplitude it is coming and going on. That's where actually that will. So that's how actually the vibration it is keep generating it, and then we were just asking to solve for 0.5 seconds. It's solving it, and now you see that previously have a very big up and down curves now, but I can see like a very small curves actually. Why? Because the source is not that much heavy now. The source is not that much heavy as there is a no vibrator at all, but in the previous step whatever the vibrations are there, still that is going to influence you small thing. That's why you can see that the stresses coming over here, it would be like a very less over there. So this is how actually you can able to carry out for this particular analysis. Okay, it's all about like the point that where you're picking and then looking for the curves and all, it's also matters you a lot actually. Yeah. So once this is done, you just go for the view calculation results. This is where the dynamic part that I will show you that with a complete animation also we can try it now. Okay. Yeah, the good part actually that we do remember that how to make the animations too as well. So we'll see that. So now you see this guys, actually I'm just going for control 2, and this is where my initial phase, and this is where when the footing is happened it. When the footing is happened, because of this particular footing, there is a huge amount of stress, the deformations happening in this region and similar to that. And after the footing, you just switch on the generator. When you just switch on the generator, now see these things, the vibrations, because of these particular vibrations, it's all coming over there till this region that you have an influence over there. Now I switch off my generator. Now that influence is almost still becoming like a null. Okay, so the deformations are like very negligible deformations. It is coming. It is between of a 0 to 0.15 meters. Okay, fine. Now, when I just go for these particular things, if you just go for the stresses to as well, that if you just wanted to see the stresses, principal effective stresses, that if you would like to see, you can able to see these particular principal effective stresses also. And if you would like to see the shear force and bending momentum diagram of the foundations also, you can able to see that. You know how to do that actually. So, but here today I will just show you one thing. When you just go for the file, you have something called as in create animation. So when you just click on this particular create animations, so it will ask you to create an animations over there. So the animations that I would like to create it on the desktop as a new project. So show the animation and what is the image width and whatever it is there, everything is the default that I'm just selecting it. Okay, so here choose this as a Microsoft Video 1 instead of an Intel. Choose this as a Microsoft Video 1 and then just give okay, so that it's going to generate the complete things over there. Okay, now just go for the media player, Windows Media Player. This would be good. Now I will repeat that and try to play the things and all. Yeah. So now if you see this actually, when you're just trying to do the animations, this is all good animation, but actually you can't understand anything in this. This is a problem or what? Okay, it's a good animation, but you can't view the animations very properly. Really don't know. It's got hang. Okay, somehow I just made this one. But if I would like to really make a beautiful dynamic animation, for that I need to do something. So for that, what I need to do is like, I just need to click on this particular generator foundations. And then when you just go for this particular numerical control parameters, okay, numerical control parameters, maximum number of a step store is like only a one step actually. But now here, make it as like 100. Okay, okay, And even this particular part also, you want make it this as like a 50 because of it's a low vibration rate thing. Make this 2 and then try to solve the equation. But now the equation solving time will also takes a lot. I mean, not to when that depends upon the complex of the geometry too as well. But when you just compare previously, it was like a half a minute. Now it may drag to some 1 minute or lesser than that too as well.
Hello.
Yes.
Sai, there will be times when footing will also be under the dynamic load. So don't we need to create another phase for that?
Dynamic. Okay. Footing also be under the dynamics.
Yes,
Yeah, we can create a one more phase for that and then you can proceed. Because
because
first,
we have created the footing in static, na. But when the
yes.
generator is on, the vibration will also be coming on the footing.
That's what, right? Generator is the source. To the source only that we have to apply the dynamics load. From the source, it will pass on to the footing, and then from the footing, it is passing on to the soil,
Uh, that's what. That is why I'm asking you that
which is the source,
don't we need to
which
create
is
a
no, we don't need to create it. We have to create for the dynamics analysis for the source part only. Who is the
okay?
generate? I mean, who is generating these particular vibrations? Only for that particular guy, we need to assign the dynamics part. Now, when you just
Okay.
go here, I create an animation with Microsoft Video 1 and then the new project AVI. Again, trying to save this also onto the desktop too as well. It's already there, so it will try to replace that too. Now see this, how slowly as the vibration increases. It's a one cycle it is forming, the other cycle now it is forming. You can see this here. Now it's like a third cycle it is performing. Now again the fourth cycle. That means a sinusoidal curve, right? A wave it is going up, coming down. That means it's pulling up the force and it is compressing the force and then it is coming to the neutral. Again it is pulling, uplifting it, and again it is compressing it, and again it is coming to neutral. So that behavior you can see that that's where actually the stresses, when it is a compressive you can see like a high amount of stresses, when it is like a uplift you can see the very less amount of forces. That's for an each and every cycle how it is behaving it also that we can able to see that. So here deliberately I just kept it as like 100 so that you can able to observe it, but you guys has to adjust it as per your presentation time, that how much you would like to show that you want to discuss it in a very detailed way, then you can go with a larger intervals of a time so that the animation will also play for a good amount of a time. But if you wanted to discuss it in a very short way, just wanted to give a glance, then go with the short. It's all up to you guys. See how actually it is shifting up all these things and all, as in which cases that you are hitting up the final boundary is also that you'll come to know that. And behavior from cycle 1 to cycle 2, how it is changing, and from cycle 5 to cycle 10, how it is changing. That kind of a detailed analysis also you can able to look into here. That I have stored this particular analysis in 50, 100 steps. And for the lesser vibration things, I have stored it for 50 steps. So it would be a very big file, I feel. Let's see that what would be the size of a file. We can see that. You can see that the animations, how it is going on here. I can see that the deformations, how it is changing on. It's increasing, decreasing. So for the dynamics part, actually, you can show very good, beautiful results of animations. See here, you might be seeing like a very lesser file. I don't know, the player here is not a good one. So you can see that how the animations is coming in the same way that you can able to see that. So I just go for this. It's around 4 MB it's got created. So, but if you still would like to go, you can just go with some 500 steps also, and then you can able to make it up like a more and more clear animations that you can able to do that. Okay. The other important part that we will see it is plotting up the graphs actually. So the dynamic analysis can be represented in two ways. One is for the animations and the other one is for the graphs. So the graphs is also like a very, very important aspect over here. So for that, actually, we have an option, right? So curves manager. So when you just click on this curves manager, you have to go for a new graph, the new thing. So here I would like to plot a graph. On the x-axis, I would like to take the time. So that's where the dynamic time that I can able to take it. And onto the y-axis, I can able to plot deformations. That's where like you can just say it's a multiplier. You can say that, or you can just say that like the force that you are applying it. So you can just apply these particular forces to as well. Okay, so you can just able to see that forces over there, and then you can able to just see these things. And at the force that I would like to see here, just give OK. To the dynamic time to the forces actually, not this. No, I would like to create. Sorry, I've closed this one, right? View the calculations part. Did I really pick some points or not that I need to check? Curves manager. Create a curve actually, where like for this particular project, I would like to consider this as a dynamic time, and for this particular things, I don't have any points to be picked it actually. So what I can do in this particular cases, you can close this one. I would like to really see the results. So to see the results that I would like to plot the curves in certain points. So which are all the points that I would like to plot it here is like, these are the things as we have applied this particular things. So exactly here, and after a little distance, how the vibration is coming that I would like to see, the second point, and a little more distance, and with a very far distance that I would like to see. Okay, so let's say I've just picked up, and if you want some, you can just pick up the first point too as well. So how the vibrations are coming at each and every point that you can able to see that. And now update this and go for the view calculations. Sometimes this will get updated with the results too as well, so that you can able to see in the graphs. But if you can't see these particular points in the graphs, then it's must and should that you have to rerun your problem. Okay, so when I just click on this, go for a new, here you can see this, like you can see all these particular points actually. Okay, so when you just pick up these particular points, the nearest one that I have selected now, the nearest one I have selected it, the node, and then okay, let's fix up this and then go for the time interval, and then to this particular point that I know calculations over there. Okay, so it's, oh yeah, let's feel free to resolve these particular two examples so that you can able to get the points over that particular places, and then you can able to see this. Now whatever you are seeing these particular things, the deformations that you are seeing it here, right? So the deformations you are seeing at the point like a 6659, that if you would like to see this one, see at the point number 23, it is like this. It's not mandatory that every point will have the same thing. As you are moving, coming nearer, you are coming nearer to your graph. Okay, as you are coming nearer to your footing, that you are like more precise to your inputs. When you are moving far away, the vibrations are very less. The deformations also would be like very less.
Sai,
Yeah.
how can we select a node in the output from coordinates?
Here, this is the option.
No, that I know. But after selecting this, now if we have to select a particular node with the help of coordinates, suppose 3,0 or 0,3, is there
Yeah, yeah,
any
yeah.
provision?
As you know the geometry, either you can able
Ah,
to search with the coordinates, or you can zoom to that particular geometry and then you can pick some nearest point.
how can I search from the coordinates? Because I
Yeah.
was doing this practical problem earlier, and I was not able to zoom to that particular node.
Hmm.
So I wanted to select that particular node with the help of coordinates.
Okay. See here, actually, you have an option. You have an option,
Oh, I have.
point of
Oh, okay, okay. I
interest
have exact
coordinates.
expanded this window. Yeah. Okay, okay, okay.
Okay. If you are using a big desktop, then there won't be any issues. You can able to see all the options, but you are using a laptop, actually, you have a problem.
Yeah, that is the thing. Now I was not able to see this. Now you have expanded when you expanded this. Now that came
Hmm.
into my attention. Thank you.
Oh, okay, fine. Hey, what I closed. The output, yeah, fine. Yeah. Now I've just recalculated this too as well. So go for the view calculations. Now to the view calculations, that if you just go for the curves, you're creating a new curve. That's where if you just want, you can select this one. Now you can see this. Previously, the calculations are not stored. That's why. But when you face that issues, try to resolve the problem, then it will be fine. So now it's a dynamic time that I need to choose it. And then here to this particular point. So what is the deformations that I need to plot it? So the total displacements, I would like to say that the compound displacement, not in the X or Y, the compound one that I would like to see. So just give OK. Now this is how actually you can see that. So as the time increases till like a 0.5 seconds, at that particular point, it was like this. After 0.5 seconds, when the generator is on off, actually you can see the very less deformations over there. To the same thing, if you would like to add a one more point, and then you have to compare the results from that particular point, how the deformations are happening, and at another point, how the deformations are happening. So just give a right click, go to the settings, or like you can just go use add curve. Okay. So you can use an add curve from the present project to itself. So in this things, actually, you're just going for the selecting this, and then you can just go for the 6409. And for the same deformations that you are adding it this. Now you can see this at 6659, the node, it is this one, and this is the one. But if you are like confused about these particular things, go for the settings. Okay. And the node 6659. So the curve title, you can just name this particular thing. Near to, sorry. Okay, you can just name it as a near. Oh my God. I'm just keeping because of my typing issues. Footing N I'm keeping. That is near to footing. So if you apply OK, then you can see that it's a footing N. So now for this particular point again, that if you want it, go to the settings here and go to this particular point, and this particular point again, you can type this footing N1. So the nearest after that, it's a 1. So now the color that you would like to choose, the yellow. Okay, apply. Okay. Now you can see it's like an overlap. So 1 point far away that you are coming it over here. I'll go and add a one more point too as well, which is a little far than that. So cancel, add curve, add from the project itself. And then you can just choose the third one and then apply. Now you see still little deformations. That is when your point is very near to your footing, that you can experience a huge amount of vibrations. As you're moving away from this particular things and all, then the less vibration that is coming in. But when you just compare to this, if you see, all the curves are like almost all near to overlap with each other. Okay, it's almost all like an overlap within each other. So this indicates that actually, as there is a no vibration source at all, as there is a no vibration source at all, that's the reason I can able to see like it's a very small quantity of the vibrations at all the places that I can able to see it, which is not a considerable one actually. Okay, but If you see this, guys, I'm just closing this to a, would like to save it. Yes, I have saved it. And now when I was just going for the results again too, let's, before getting into that, I would like to go here. And now here actually what I can do in X direction is something like around 0.65 I would like to go. And in the Y direction is something like around minus zero point 0.5 I'm just going. It's at the depth wise. So when I just search for the closest one actually, these are all the, oh, sorry. The bottom it should be my mouse. Hey, come on. It is there actually. You guys can see this. So when you just click for the search closest one, and these are all the points that I'm going to get it. So 0.65 exactly I didn't have, I have at a node, and but 0.5 exactly I didn't have. Either it is like 0.6, 0.52 I go, or like 0.46 I can go. So I'm just going for this particular things and all. Okay. After selecting, these are all the nearest points that I can able to get it for this things and all. And now I just got to select this particular things. If you are like would like to select by any kind of an ID also, that you can able to select this. But still there should be some more option. Why it's not adding? Oh, okay, okay. It's 1, 2, 3, 4, 5 points that I've just bring it up. So then I have to pick this particular node number, as it's getting me the node number. Then automatically I have to just plot these particular node numbers, and then I can able to add for this too as well. But in an older version, there is an option called as an add this point. These are the stress points, but these are the nodes. Nodes I can able to add. Here, previously I have an option here, and then I can go to add points. But in this newer version, actually, they have given the nodes, and you just click on this one, then automatically that point is adding. This point is adding. This point is adding. This point is adding. This point is adding. Okay. In my original version was like little old one, which I'm not under the maintenance part. Okay, this is how you can able to pick up these particular points and all. Then automatically it will able to pick all the points over here. See this. And now you can update this one, or it's really going to do without any calculations for all the things. Let's go and check for this. Sometimes it will and sometimes it will not. I plot for the curve, a new curve that I'm going here. But the time as a dynamic time, and to this I have all the points. So let's pick up a point which is near to that. I have no calculations for this. So when there is no calculations, don't be get stressed of yourself. Think that the calculation was really not at happened it. So rerun the problem. But sometimes for the dynamic analysis, it takes like 8 hours or 10 hours. So for that, don't play like this. Be careful what are all the points that you need to plot it. But unfortunately, if you could not able to fulfill all the points, it is must and should that you have to rerun that. So these kind of a jobs normally, preferably select in the night time so that you keep for a run and the morning when you're coming back, so you can just validate your results as well. Yeah. So this is how you can able to plot curves also for the dynamic equations and as well as animations too as well. So try to work out on this particular parts and try to consider the earthquake analysis too as well. So the earthquake analysis is something like you have to go to the structures, and then here you have to write up this like your line load, and then you have to give this particular line load at the bottom. So that's why in the only the y minimum region that you have a compliant base. Try it, but you have a sufficient amount of examples too as well before that we were meeting it. So all these particular things that has been done. So I will mark this as a done, that if you have any questions, I'm happy to reopen this. But you can just try working of this. I have just added all the attachments to this. So start working on it one by one and then try to push it. But if you have any doubts, feel free to approach me over the phone too as well. Yeah. With this, I would like to take a pause. And do you have any questions?
None.